Dear friends, today we will see about the model analysis in fluid mechanics. So what is meant by model analysis? Model analysis gives the relationship between a model and a prototype. So what is meant by model and prototype? So model is the small scale structures and prototype is the actual structures. Small scale structure of actual machine. This one. So this is the actual structure of machine. So So this is called prototype and this is called a model. This is, you can say B, and this is B in model, and this is so whenever we say both are similar in shape, but dimensions are different. So if you want to have the relationship between model and the prototype, we can have the relationship something like this. Length ratio equal to dm by dB. This is also we can see as Lm by Lp. This further we can write it as H in the prototype and H in the this one, H by Hb. So whenever we satisfy such kind of relationship, and this is also called a length ratio, then we can call it as this is geometrically similar. Then such kind of element called as geometrically similar in model analysis. So this is for geometrically similar. If we want to have the geometric similarity, we should have the similar shape, say that means same shape but with the different dimensions. Then only geometric similarity exists. Now we will consider this so this is called aerofoil, and in this we will see the fluid flows. Fluid flow patterns are something like this. fluid flow patterns are represented by the streamlines. Something like this. So in both the cases, what is happening? Both are having the similar motions. Both are having the similar motions. So whenever we say both the model and the prototype having the similar motions, we can call it as, these are called kinematic similarity. Kinematically similar. When we see the both the streamlines over the aerofoil in the prototype and also the similar streamlines over the model, so if both are having the similar pattern in the sense similar motions over the prototype and model, then we call it as kinematically similar. Then for example, if we have some kind of point here, similar point, we call this, take it as this is point 1, this is point 2. So if the point 1 in this and point 1 in the model, they both are having the similar dimensions, the similar locations, so it means with respect to the geometric aspect, both are having the similar dimensions. So whenever we get this kind of relationship, then we call it as kinematic similarity. Also has the geometric similarity. So whenever we say this condition exists, it means geometric similarity also exists in geometric similarity also satisfied. So then we can say that kinematic similarity exists. It means whenever we have the kinematic similarity, geometric similarity is the necessary condition, and it is not just the sufficient one. It should be the necessary condition in order to have the kinematic similarity. So not only here, if I want to another point here, this point also I just take it as 2, this point 2, then both of them should have the same with respect to the locations in prototype and model should have the geometric similarity. Then only similar motions are maintained in prototype and model. So in the case of dynamic similarity, so if it is nothing but similarity of masses, and forces. So it means force in the model divided by force in the prototype. So is nothing but force ratio. So it should be satisfied in the case of dynamic similarity. So with respect to the forces, we have a different kind of forces. Those forces should be taken into account while satisfying the dynamic similarity. So thank you.